This question asks us to find the binomial expansion of this expression here and state the values for x for which that expansion is valid. And we're going to start by doing this by expressing this in partial fractions. So firstly, what we need to do is to find values of a and b such that this is true. And we should have had lots of practice at doing this by now, so we can see that this is equal to a lots of x plus 3 plus b lots of 1 minus 2x all over 1 minus 2x, x plus 3. And because this is an identity and it's true for all x, in particular we know that 7 is identical to a plus a lots of x plus 3 plus b lots of 1 minus 2x. And this is true for all x. So let's take x equals negative 3. We get 7 is equal to, well, negative 3 plus 3 is 0. So we get b lots of 1 minus 2 times minus 3. So 7b. So b is equal to 1. Now let's let x equal a half. If x is equal to a half, we get 7 is equal to a half plus 3, so 7 over 2, lots of a. And then this next bracket, 1 minus 2 times a half is 0. So multiplied by 2 and divided by 7, we get a is equal to 2. So in partial fractions, we have that 7 over 1 minus 2x, x plus 3 is equal to 2 over 1 minus 2x plus 1 over x plus 3, which is equal to 2 lots of 1 minus 2x to the power of negative 1 plus x plus 3 to the power of negative 1. So we can find our binomial expansions of both of these. We can then just add those terms together. So let's do these as a little aside. So the first one is 1 minus 2x to the minus 1. Well, this is equal to 1 plus minus 1 lots of minus 2x plus minus 1 minus 2 over 2 factorial lots of minus 2x squared plus minus 1 minus 2 minus 3 over 3 factorial lots of minus 2x cubed plus some higher order terms. We don't need to go any further because it asks for in the first 4 terms. Well, this is equal to 1 plus 2x plus 4x squared plus 8x cubed. We need to do a similar thing with x plus 3 to the minus 1. Well, notice this is open brackets 3 open brackets x over 3 plus 1 close brackets twice to the minus 1, which is 1/3 of 1 plus x over 3 to the minus 1. So doing the binomial expansion, we have 1/3 of 1 plus nx, which is minus 1 lots of x over 3, plus minus 1 minus 2 over 2 factorial x over 3 squared, plus minus 1 minus 2 minus 3 over 3 factorial lots of x over 3 cubed, plus higher order terms, which is 1/3 of 1 minus x over 3 plus x squared over 9 minus x cubed over 27 plus the higher order terms. So making these two substitutions here, we can simplify our expression by collecting like terms. So we have equal to 2 lots of 1 plus 2x plus 4x squared plus 8x cubed plus a third of 1 minus x over 3 plus x squared over 9 minus x cubed over 27, which is equal to 2 plus 4x plus 8x squared plus 16x cubed plus 1/3 minus x over 9 plus x squared over 27 minus x cubed over 81 plus the higher order terms. And now just collecting like terms, this is 2 plus a third, so 7 over 3, 4 minus a ninth, which is 35 over 9, lots of x, 8 plus a 27th, which is 217 over 27 x squared, and 16 subtract 181st is 1295 over 81 x cubed plus the higher order terms. And finally, we're asked to state when this is valid. Well, this first binomial expansion is valid when 2x is between -1 and 1. So x is between -1/2 and 1/2. The second expansion is valid when x over 3 is between -1 and 1. So x is between -3 and 3. But which is the strictest of these criteria? Well, this is a far stricter criteria. So this is valid when x is between -1/2 and 1/2.